Okay, this is number 5 from the homework. So it says find the exact value of the expression. This is expanded. We're going to condense it. Cosine, cosine, sine, sine's pattern is cosine, and we change the positive and negative. So this would be pi over 16 plus 3 pi over 16. And I get cosine 4 pi over 16 pi over 4. And the cosine pi over 4 is root 2 over 2. Okay, number 7 says find the exact value of the trig expression given that the sine of u is 18 over 17 and the cosine is 21 over 29. So if I draw out my triangle, sine would be 8 over 17, and then v cosine 21 over 29. It says they're both in quadrant 2, which means the negative is going to go on that 21. This is another triple. This would be 20, and this would be 15. So the one on the right is not that common of a triple, but it is a triple. So then from here, I want to do cosine, cosine, sine, sine. So cosine of the first, which over here is v first. So I want to do cosine of v, cosine of u. Change your sign. So because it was negative, it becomes positive, plus sine of v, sine of u. So I have to use this second triangle first. 20 over 29 times, oh sorry, that's cosine. Cosine would be negative 21 over 29. Cosine 15 over 17. This should be negative. Negative 15 over 17. Plus the sine of v, 20 over 29. And the sine of u, 8 over 17. So 21 times 15. This is positive 315 because they're both negative. 29 times 17. 493 plus 160 over 493. So I get 475 over 493, which was this answer. The next one, another set of triangles. This time u sine 5 over 13. This side is 12. V cosine is 8 over 17. They're both in quadrant 3, which means both the vertical and the horizontal are negative. So the 8 is negative and the 15 would be negative. So then tan of u plus tan of v over 1 minus tan of u times tan of v. Tangent of u is negative 5 over negative 12, or positive 5/12, plus tangent of v, negative 15 over 8, or 15 over 8, over 1 minus 5/12, 15/8. So in the numerator, I gotta now change your numerator so they have the same denominator, so I can make it 24. And that becomes 10 over 24 plus 45 over 24. This is 55 over 24. And then the denominator, this actually simplifies 4 and 5, and I get 25 over 32. Make this 32 over 32. And I get 7 over 32. And then keep, change, and flip. Both divisible by 8. 55 times 4, 220. Over 7 times 3, which is 21. Number 10 says find the solutions on the 0 to 2 pi interval. So I'm going to expand this first. I would do 8 times cosine x cosine 7 pi over 6. Change the sign on cosine so it's minus. Sine x sine 7 pi over 6. Minus 8 again. Cosine x cosine 7 pi over 6 plus sine x sine 7 pi over 6 equals negative 8. So you can actually divide everything by 8 to make it easier. 7 pi over 6 is negative root 3 over 2 and 1/2. Negative 1/2. So this would be negative root 3 over 2. And this would be negative 1/2. And then the 8's gone again, so this would be cosine there. So now when you rewrite this, it's negative square root 3 over 2 cosine x plus, because this is a negative and a negative, 1/2 sine of x. This negative goes to both of these terms, so it ends up being minus a negative, which is plus root 3 over 2 cosine x, and then a negative times this negative makes it a positive 1/2 sine of x equals -1. So negative square root 3 over 2 cancels with positive square root 3 over 2. 1/2 plus 1/2 is 1 sine of x equals -1. And then you're looking for where sine is -1, and that happens at 3 pi over 2 on the interval of 0 to 2 pi. Like 5/2 itself is not really on there. 5/2 where there's an equals and there's something on the other side is not on there. But it is like 5/1 with choices because it's multiple choice. So any questions on 5/1? Remember that these odd answers are on the old Calc Chat link, okay, the ones that are on the review, so I can add that directly to the assignment. But anytime that they're in the, like they're from the old book, the PDFs and that kind of stuff, they're going to be on the old Calc Chat link, which was on the quiz review, which was like all that stuff.
Wait, so there's no like verifying?
There is verifying, but it's not equal to. So it's more of like a simplifying. You don't have the equals.
This page is like 5.1 to 5.3 to 5.4.
Yeah.
Okay, thank you.
You're welcome. And there's only 2 of those, like simplifying. I thought I said that on Thursday. There's only 2 of the simplifying, and then there's like so that you're solving of your equations, that kind of stuff, and then the 5/4, which was the sum and difference. So you have to use the identities to solve some of those equations. Use it, and you have to use the identities in your sum and difference. But there's less of them. Remember on the quiz there was like 6. There's less of them on the test. Okay, any questions on the first page while I'm on it? 5/1, 5/2, or 5/3, which was the solving of the trig equations?
For number 18, shouldn't it be positive?
18 is the solution on here? I don't even know where it is. 18.
It's the blue in the top left.
Thank you. Yeah, the secant goes, the negatives on the angle. Yes, this becomes positive secant squared over cosecant squared. Yeah, that should be positive. Thank you, Sophia. Because remember, secant and cosine are even functions, right? The negative on the angle goes away. Yep.
How many do 29?
29. Yeah. Okay, so let's pretend like the equals is not there, because it won't be there. Okay, so you can from here take out a sign on both those, right? Sine of theta, sine squared theta plus cosine squared theta, and then this is your Pythagorean identity, so it'd be sine theta times 1, which is sine. With the equals, you could have divided both sides by sine and then ended up with 1 equals 1, but you won't have that equals, so just be careful.
Thank you.
You're welcome. Other questions from this first page? Be really careful on your interval. Oh, I will say this. This is what's different sometimes about the interval. Let me see if I can find an example. If not, I'll make one up. When you're dealing with like a multiple choice. Okay, so let's say 55. So 55 says 2 sine 2x equals square root 2. I would solve it. I would divide both sides by 2. And I would get sine 2x equals root 2 over 2. Oops. Now it doesn't give me an interval, which means I'm going to add on my 2n pi, right? So sine is root 2 over 2 in what 2 angles? Pi over 4 plus 2n pi and 3 pi over 4 plus 2n pi. So now it's 2x equals this, right? So 2x equals this. So when I divide by 2, this becomes pi over 8 plus n pi, divide by 2, and this equals 3 pi over 8 plus n pi. So sometimes in adding n pi to this, it gives me this angle. So with sine, it doesn't, because pi over 8 would be over here, 3 pi over 8 would be here. They're both in the same quadrant, so I need to add on the half pi. But let's say that let's say it ends up being pi over 8 plus n pi, and it's tan. So then it would also be like 9 pi over 8 plus n pi, okay? Let's just say we got those answers at the end. This pi over 8 plus n pi is 9 pi over 8. So this answer is actually like a duplicate answer that multiple choice will not give you. So if you are looking at your answers and you're like, but I got both these answers and they're not both there, make sure that it's not a duplicate answer. If it's a duplicate answer, you're fine. Just keep this one, okay? But I'm pretty sure there's one on every test version that's like that. Like there is one that says a duplicate answer and it doesn't include it in multiple choice. If it was open-ended, I'd give you credit for both, but it's going to be multiple choice and it's going to throw you off, and I want you to know why it's happening, okay? So again, like if you had whatever it is, let's say I had pi over 2 plus n pi, and then I end up with 3 pi over 2 plus n pi, I would not keep both of those answers because pi over 2 plus 1 pi is 3 pi over 2. Does that make sense? So I made sure that there's not another answer there that should throw you off. It should be pretty obvious that's going to happen, okay? But realize that that's what it is. That if there's a duplicate answer, you don't keep both. To know to add 2n pi or n pi is based on your instructions. So if it says on the interval of 0 to 2 pi, you do not add the interval unless it's a multiple angle, okay? If it doesn't say 2n pi, then you add the angle. So remember the multiple angles got really messy when you had to have the interval and the multiple angle. So I said I'm not going to include that. That's why I crossed it out on this one. Like that's why this is crossed out, okay? Because you'll treat it as though it doesn't have the interval. You set it up though it does, and then you get rid of it. But those are the ones that got really tricky. Any other questions from that first page?
Miss Chris Weiser,
Yeah.
I'm so confused on why for 45 you add n pi instead of 2n pi. I mean, I know that n pi adds for like the other two angles, which is 4 pi over 3 and 5 pi over 3, but I don't get why it's 10 pi instead of 2n pi.
Well, here. Oop, x equals 4. All right, so divide both sides by 3. Cosecant squared x equals 4 over 3, which means I'm looking at sine squared x equals 3 over 4, plus and minus the square root, and I get sine x equals plus and minus root 3 over 2. So normally this is all the over, and that's exactly, so this is a perfect example of what I was just talking about. Normally this means this is all of the pi over 3's, right? It would be pi over 3 plus 2n pi. It'd be 2 pi over 3 plus 2n pi. It'd be 4 pi over 3 plus 2n pi. And it'd be 5 pi over 3 plus 2n pi. So on a short answer question, you could keep all those and I would have marked it wrong. But this is the same thing as saying these two plus n pi. It's saying take this angle, add n pi, add half, like all the way around. take this angle and do the same thing, and that covers all 4 angles. So that's a perfect example of what I was talking about before, that if it's short answer and you write all 4 of them, you're totally fine. But a standardized test is not going to give you all 4. It's going to simplify that bank, and it does it like that. So that pi over 3 plus n pi is 4 pi over 3. And 2 pi over 3 plus n pi is 5 pi over 3. So it simplifies your bank, cuts it in half, and makes it n pi. Does that make sense?
Yeah, it does.
Okay, that's the trick with a multiple choice or a standardized test, is it's going to do that. Any other questions? Sophia Gonzalez, I still need to see your camera. Thank you. Thank you. You might want to warn your parents because I had to mark you absent. I'll email Miss Pierce after class, but until then, you might want to just give them a heads up. All right. Any other questions on this page?
I looked at it and then I tried to do, but I couldn't really figure it out. So.
Okay. So I probably would have taken the sign out of the bottom. Let me think. And then the top is actually the difference of 2 squares.
Because I looked at it, if it had a plus.
If it was a plus, it's a 1, but it's not. So it ends up being the difference 2 squares. So it's sine plus cosine, and then sine minus cosine. And then the sine minus cosines cancel out. And I end up with sine of theta plus cosine of theta over sine of theta. And then that, you can actually split that up into 2 separate fractions. Sine of theta over sine. And cosine, I mean not theta, that's alpha, but cosine over sine. And sine over sine becomes 1. And cosine over sine becomes cotangent. Trying to think if there's another way I would have approached that. Probably, I think that's the only way my brain sees it. I don't know if that's the only way to do it, but that's what I would have done. And this is not verifying, right? Yeah.
Why 1 plus?
The 1 is from the sine over sine. So if I take this and I actually split it into 2 fractions, both of them get that denominator.
Oh, so you can't just cancel it like.
No, because it's not on both parts. If it was multiplication, yes, but addition and subtraction, no. Any other questions from this page?
Sorry.
That's okay. Isabella, go ahead, tell me. I'll do both.
51.
Okay, and then what was the other one?
You do 28.
28. Okay, 28 and 51. Okay, so 28. Secant squared x, cotangent x minus cotangent x. I would say even leave off the right side so you pretend like you didn't even know it. And this becomes 1 over cosine squared x times cotangent, which is cosine over sine, minus cotangent. Actually, you could have also taken out, let's do that. I want to take out a cotangent instead. Cotangent x times secant squared x minus 1. And this comes from your Pythagorean your triples. So I would do, this would be tangent squared x plus 1 equals secant squared x. So secant minus 1 is tangent squared. And then cotangent is 1 over tan squared. And that leaves just 1 tangent at the end. You could have gotten there the other way too. I feel like maybe it would have been more steps, but you definitely could have gotten there the other way too. You're welcome. Okay, 51. 2 cosine squared x minus cosine x equals 1. And this one's on the interval. So we've got, this is where we get to solving, but it's on the interval of 0 to 2 pi, so we use our natural unit circle. So as soon as I see the squared and the cosine to the first, I know I'm going to end up having to get everything to one side to factor it. And then I want to factor it to cosine of x, and then cosine of x, factors of -1, that when multiplied the outer and the inner gives me the -1 in the middle, would be a +1 here and a -1. That's -2 cosine plus cosine, which is the negative cosine I want. Then I split them each and set them equal to 0. I'd get 2 cosine of x equals -1, cosine of x equals +1. One step further on the left gives me -1/2. So because it's on the interval, I'm looking for everywhere from 0 to 2 pi. It said it in the instructions, 0 to 2 pi, not including 2 pi. Then my cosine's -1/2. And that happens at 2 pi over 3 and 4 pi over 3. And then where cosine is +1, which is at 0. So those three would be the answers if it's restricted. So pay attention to this, because this is what's different about, like, if it's short answer, you can put it one way, but if it's multiple choice, you're not going to necessarily see it that way. If this was not on the interval and it had actually just said solve it, it would be 0 plus 2n pi, and then 2 pi over 3 plus 2n pi, and then 4 pi over 3 plus 2n pi. And this 0 will be gone. So 0 plus 2n pi is going to just be written as 2n pi, and then the rest would be there. But just keep that in mind when it's multiple choice like that. If 0 is the answer by itself without the interval, then 0 would be listed. But if there's the interval added on, then it's just going to give you the interval and not the 0 plus the interval.
Can you also do 56?
Mm-hmm. 56.
And I got the answer, but then your answer was like a little bit.
Okay, so 56 was that tangent? Oh, root 3. Tangent 3x equals 0. Right? Yeah, 56. So first thing I got to do is divide both sides by root 3. And I get tangent of 3x equals 0. Right? So tangent is 0 at 0. Plus n pi.
I got that one.
Now 3x equals that.
Isn't there also pi though?
It is, but by saying plus n pi, that is pi.
Oh, so you don't have to put both?
And it, not only that, but it won't include it in your answer choices. So that
would be multiple choice?
yeah, they're all multiple choice.
Oh, okay.
So that's what you want to be really careful about. Like if that was an answer that you wrote on a blank, I would give you credit for it. But because it's multiple choice, both won't be there. Just don't get confused.
Oh, okay. Yeah, because I had both.
So then you divided by 3, right? And you got 0 plus n pi over 3. On your test, your answer is going to just be n pi over 3. That would be the only solution listed. So that's the difference between, like multiple choice perk is there's answers there, which usually makes you feel a little bit better. You're not going into it completely blind. But it also means, one, no partial credit. And it means that like you have to be so very careful to watch for the negatives, watch for the positives. But it also means the format of standardized answers here are going to be different. So just be careful. So like there's one, I think I did it on the next page. Where is it? Here, which number is this? Question. So I'm going to pretend like the right side's not there because that's how it will be, okay? So the left side, cotangent squared x minus cosine squared x. Cotangent becomes cosine squared x over sine squared x minus cosine squared x. And then to give them one like denominator, I'd have to multiply by sine squared x and sine squared x. So cosine squared x minus cosine squared x times sine squared x over sine squared x. Then I would take out the cosine. So cosine squared x, 1 minus sine squared x over sine squared x. This becomes cosine squared x. So I'd get cosine squared x times cosine squared x over sine squared x. That could be cosine to the fourth x, but it won't be a choice, like over sine, because you can break off the cosine and then group together the cosine and the sine. And I'd get cosine squared x times cotangent squared x. And that would be an answer choice. So the good news is it's multiple choice. So like where you would normally wonder if you got to the end as far as you can get, you can look at your answer choices, and if it's not there, then you know you have to do something different.
Thank you.
You're welcome. Everybody else is good? All right. All right. Then came 5-4. So this is our sum and difference. Let it come into focus. Hopefully it'll load. So you're going to get sum and difference with degrees. You're going to get sum and difference with radians. You want to make sure you're comfortable with both of those. You're going to get the ones where you have to condense them. And then I would say even take it a step further. So you're going to get questions like 71 and 74 that you can actually simplify and find the exact value. So if I was to put those together, like sine, cosine, cosine, sine, right? Sine, cosine, cosine, sine is what pattern? Sine, cosine, cosine, sine is what pattern? Oh boy.
That is
Sine. We keep the positive or negative, or we change it with sine. Keep it. So for 71, this would be 130 plus 50. That would be sine of 180, which means you can actually find it because at 180, sine is 0. So that's an example of those 6-point questions. You're going to have 2 of those where you have to condense them and then actually find them.
But that's when, like, if it didn't add up to 180 and it wasn't on the circle.
You would leave it. So like 74 had to be left like that. Like there's negative 49 is not on your unit circle, so it got left like that.
Okay.
And then came the triangles, your sum and difference. Make sure you know your triples. And then 81 and 82 picture without the right-hand side. Could you simplify it without the right is kind of what you need to be able to do. You're going to have solving with the sum and difference. You're going to have simplifying with sum and difference. Okay? You won't have verifying where you know the right-hand side. I'm so excited for how well prepared you are. I'm so looking forward to seeing this high average for tomorrow's test. I literally tried to give you an easy one at the end, but I'm not sure you've done your part yet, which means you've got a long evening ahead of you for some of you. All right, we're going to do quick. All right, so 81 without the left-hand side is what I would practice. Cosine x plus pi over 2. So this is cosine, cosine. Change the sign so it's minus. Sine, sine. So the only angle we have information on is that pi over 2. We know nothing about the x, which is 0, 1. The cosine of x is going to stay as the cosine of x. The cosine of pi over 2 is 0. The sine of x is going to stay as sine of x. The sine of pi over 2 is 1. This goes away, and I get negative sine x. So again, that would be an example. It won't give you the right side. It would be multiple choice. And that would be one of the options. Your 82, oops, a daisy, says sine of x minus 3 pi over 2. And I'm going to pretend like the cosine's not there because it won't be. So this is sine of a difference. Sine of x, cosine 3 pi over 2, minus cosine of x, sine of 3 pi over 2. 3 pi over 2 is down here at 0, negative 1. Sine of x, I don't know. Cosine there is 0. Cosine of x, I don't know. Sine there, negative 1. So this goes away. I end up with negative cosine of x. So it gives you the 315 and the 330. Do I have to do all three, or you want to pick a sine, cosine, or a tangent?
Just do sine.
Sine. Okay, so sine of the first, cosine of the second. The positive and negative sign stays the same, so I do minus. Cosine of the first, sine of the second. So at 30 degrees, my coordinate point there is root 3 over 2 and 1/2. And at 315, my coordinate point there is root 2 over 2 and negative root 2 over 2. So I'd get sine at 315, negative root 2 over 2. Cosine at 30, root 3 over 2. Minus cosine at 315, root 2 over 2. Sine at 30, 1/2. Negative root 6 over 4. Minus root 2 over 4. Negative root 6 minus root 2 over 4. And then the root 2 is going to come out. And look like that. Root 2 times negative root 3 minus 1 over 4.
Now what happens to the
You have
285?
To the what?
285.
No, it just told you to use those two angles. Nothing happens to the 285.
What?
It just gave you which angle. So it could have said 285 and then you choose the angles to use.
Oh,
Or it will give you the angles to use like that.
okay.
So you have to take it out like that?
Yeah, again, it'll be multiple choice on that and it won't be in, it will be out like that. Yeah.
The sign, the numbers put 315. Because it kind of looks like an S.
The sine is sine of 315.
Okay,
Yes,
'cause it kinda
yes.
looks like an S.
Sorry. And then the cosine, I would do cosine, cosine plus sine, sine. And then the tangent, 1 minus tangent. I'm sorry, tangent plus, what was the original minus? Tangent minus tangent over 1 plus tangent times tangent. So those would be there. And those are on the odds, like those are worked out on the calc chat if you need to see each individual one. Okay, again, I put the link to that calc chat because that's the old book directly on the assignment.
Miss Christmas,
Yeah,
could you do number 30?
sure. So 70, 23 pi over 12, but it gives you that it's 7 pi over 6 plus 3 pi over 4. So this is kind of what I did on the test. I didn't do the 23 pi, like where you have to break it apart. I gave you the angles so that you're in the same order. So it will look like this, right? So then I can do the sine of this. So sine of 7 pi over 6, cosine of 3 pi over 4, plus cosine 7 pi over 6, sine 3 pi over 4. So 7 pi over 6 is negative root 3 over 2 and 1/2, and root 3 and 3 pi over 4 is negative root 2 over 2 and root 2 over 2. So the sine at 7 pi over 6 is 1/2. The cosine at 3 pi over 4 is negative root 2 over 2. The cosine at 7 pi over 6 is negative root 3 over 2. And the sine of 3 pi over 2 is root 2 over 2. So I get negative root 2 over 4 minus root 6 over 4. You can combine that into 1, negative root 2 minus root 6 all over 4. And then you got to take the root 2 out, and it'd be negative 1 minus root 3 all over 4. So this would be the format of your multiple choice. And be careful, because it's going to say that, and then it's going to say like positive 1 minus root 3, and then positive or negative 1 plus root 3, and so it comes down to the signs. You got to be really, really careful. The cosine, same values, right, but different pattern. Cosine is cosine, cosine, sine, sine. So cosine 7 pi over 6, cosine 3 pi over 4. Change the sign so it's minus sine 7 pi over 6, sine 3 pi over 4. The cosine at 7 pi over 6, negative root 3 over 2. Cosine at 3 pi over 4, root 2, negative root 2 over 2. Sine at 7 pi over 6 is 1/2. Oh, this should be negative. Did I do that wrong? Yep, that should be negative. That should be negative. Makes that positive. Positive, positive. So sine at 7 pi over 6, negative 1/2. And the sine at 3 pi over 4, root 2 over 2. So positive root 6 over 4 plus root 2 over 4. Take out the root 2 all over 4. And then the tangent, tan of the first, match the sign, so it's plus. Tan of the second over 1 minus tan of the first, tan of the second. And tangent, this was my over 4, so it's a negative 1. This is my over 6, so it's root 3 over 3. So root 3 over 3 plus a negative 1, so minus 1, over 1 minus root 3 over 3 times negative 1. And then I have to find the like denominator, so root 3, this becomes 3 over 3, minus 3 all over 3. This is 1 plus root 3 over 3, so this becomes 3 over 3. 3 plus root 3 over 3. Change, flip. Root 3 minus 3 over 3 plus root 3. And then multiply by the opposite. So the numerator becomes 3 root 3 minus 3 minus 9 plus 3 root 3 negative 12 plus 6 root 3. And the denominator is 3 squared minus root 3 squared. 9 minus 3, which is 6. So negative 2 root 3. Negative 2 plus root 3 is the tangent. Question. So you won't get a question that has all 3. You'll get one of those. Yeah.
Would one question be asking for like us to find like sine, cosine, and tangent?
No, it's just going to ask you for one of them. Yeah, it's just the luck of the draw which one you get.
How many questions are there?
13.
And also, for like, can you go back to like sine? When you're like taking the 2 out, can you explain how you do that? Like at the bottom.
So you're good on this step?
Yeah.
Okay, so I've got root 2, ooh, I say 2 and root 2 minus root 6 over 4. So you're always going to be able to pull out a root 2. And by pulling out, we mean like divide this by root 2 and divide this by root 2. So the root 2 goes on the front. Root 2 divided by root 2 would be 1. And then root 6 over root 2 would be root 3. And then they'd all go over 4. If you want to double check, you could always reverse it. Take your answer and multiply the root 2 back in and make sure it matches your initial.
Okay, but you said like a root 2 will always be divisible by root 3?
No, like your tangents weren't divisible by root 2. But like if you get a combination of an over 6 and an over 4 or an over 6 and an over 3, you're always going to be able to divide by root 2.
Okay, thank you.
You're welcome. Because I made it. I'm going to go over the ones that didn't like, a lot of them, you guys did really, really well. But this one, I would distribute here and I'd get sine times cosecant minus sine squared. Sine times cosecant becomes 1, that becomes 1 over sine, is 1 minus sine squared. And that's cosine because of your trig identity. Or your Pythagorean identity. This one, you have to expand. I'd FOIL it out and I'd get secant squared x minus 1, which is tangent squared s, another Pythagorean identity. This one, tan times cotangent, which would be 1 over tan, minus cosecant squared x is 1, minus cosine. 1 minus cosine squared x, which is sine squared x. So almost all the ones you guys were wrong are your Pythagorean identities. You guys definitely need to review those, okay? That is a wait. That's not because it's not squared, okay? The secant has to be squared. All right, the rest of them good. All right, let's do one more. All right, let's do this fast. You won't get probably through all these, but I'm gonna let you get as far as you can so I can get some feedback on what you need to get covered, and then I'll post it on the module, so I'll leave it open if you want to get back into it later. Starting in 10, 9, 8, 7, 6, 5, 4, 3, 2, go. All right, so here's a couple that are just missed, like sine of root 3 over 2. This should happen at pi over 3 and at 4 pi over 3. It didn't give the interval, so we add on to n pi. Not 4 pi over 3, sorry, 2 pi over 3. 2 pi over 3. Cosine squared being 1/2 means that it's cosine plus and minus root 1 over 2. That becomes plus and minus 1 over root 2, plus and minus root 2 over 2. On the interval, this is all the over 4s, okay? Remember, if it wasn't on the interval, that I would do my over 4s. 3 pi over 4, 5 pi over 4, and 7 pi over 4. And normally it would be plus 2n pi, but this can get eliminated, and so can this. And we add n pi this time. So pi over 4 plus n pi, 3 pi over 4 plus n pi. So again, without the interval, it's all of them, okay? And then with the interval, it's all of them. And then without the interval, so we don't duplicate answers, and you will see it in your multiple choice, they won't both be there, okay? That one would be there. This one, I have to do 1 minus sine squared of x plus sine x plus 1, and I get negative sine squared x plus sine of x plus 2. I would move everything to the other side so the sine is positive. Factor it. Negative 2, positive 1. Solve it. There is no such thing as the unit circle sine of x being 2, so I ignored that one. But sine of x can be negative 1, and it happens at 3 pi over 2. Again, that one gave you the interval, so you don't add on the 2n pi. If it didn't give you the interval, you would. The last one I'll cover, and then I'll let you go. Cosine of x2 equals 2 cosine of x. Divided by 2. Cosine of x equals 1. That happens at pi. And again, plus, or no, if it didn't have the interval, that one did. It's just pi. That's a lie. It happens at 0, okay? If it didn't have the interval, it would be 0 plus 2n pi, and multiple choice is going to ignore the 0 and just do 2n pi. I had kids from the last class ask for an extra review if they've already done the last one, so I said, okay, I'll add it on there. Do you want it on a separate assignment so you know to do it on your to-do list, or do you want it just built into the review? Separate. Okay, I'll put an extra review on there. Okay, if you've already done the review from the weekend, fantastic. Then I'll try to throw on like 1 or 2 of these where it kind of like changes the format of your answer so that you know to look for it.